In this, uh, we are taking Cartesian coordinate systems. Okay. So Cartesian coordinate system. Okay. So in this, we would like to find out the differential length, the differential length, the differential volume, sorry, differential surface, and differential volume. So three things are needed in this. So this is number one, and this is number two, and this is number three. But initially, what is required is that we need to first of all understand in, in what way, from where to where we want to travel. Suppose say we are traveling from A to D. So this is A. So we have to see that to approach D, we have to travel in all the axes. Okay. So from A, okay, let us say from A, we travel like this. So this is dy, and we travel like this. This is dx, and then we'll travel like this. This is dz. So there are three directions. In the three directions, we are trying to travel to approach D. So we can also travel in another way. We start from A to F, that means Z direction, F to G, Y, G to D, X. So we can also do that. So first of all, let us say we are traveling, you know, we are traveling in one direction. Suppose it dx. Okay, so dx में हम लोग अगर जाते हैं, so suppose say we travel like this. So this is dx in the delta x direction. Okay, from there what we can do, we can go to, that means this is delta x vector. Okay, again we travel to c, that means dy, that is delta y, that is in the direction of y, and there is dz, that is in the direction of z. So there are three components with which we can travel to reach from A to D. So we can also say that I start from B, I want to go to E. We can think of many things. So we are actually traveling, or we are actually trying to reach out from one point to another point. And what is the differential length is, this is the differential length. So what is the differential length? dl bar is equal to dx direction, that means delta x, plus, that means this is conical delta, dy delta y plus dz delta z. Okay, this is number one. Once we understand how to get differential length, we obtain differential length, the differential surface and differential volume are easy. But first, see control volume. This particular box is known as the control volume, or we can say differential element. Differential element. Now coming to the differential surface, okay, let me come to the differential surface. Suppose I have dl as what? So dx into delta x, that means x direction, dy delta y, that means y direction, dz delta z, z direction. Now, if I want to try to find the area, that means surface is also a vector quantity, length is also a vector quantity, but this has three components, that means ds1, ds2, and ds3. There are three surfaces. So, as we see in this length quantity, if you consider this one and this one, that means you are considering two dimensions of the length, which is that we are not considering. So let me take one volume here. So if I do like this and then like this, so this is x and this is y and this is z. So what do I do? This is x direction, this is y direction. So this is my area. But this is what, this is dx and this is dy. There is something shape. This can be a square, this can be a rectangle. What is area? Very simple. Dx into dy. But what is the direction which we are looking? What is the component we have not taken in the first case? That is S1 differential a surface 1 is this. So direction which we have not considered is AZ or delta Z. है? So into delta Z. That means you have to say what is the direction. So this is known as the surface 1. Similarly, if I consider the other one, the other one, what is the other one now? Again, let us draw something simple like this and then like this. So this is Z direction, this is X direction, this is Y direction. Now we will take, uh, that means like this and then like this and then like this. Okay, this is Z, this is Z, and then this is Y. What is that we are now we are considering with this particular area? Which is that we are not considering, that is X1. So we have to find that direction. So D S2 becomes dy into dz into delta x. Similarly, ds3, what will happen with respect to ds3? That means area ds3. So we need to be careful here. In ds3 means very simple. In the length vector, in the length, differential length, we have dx delta x plus dy delta y plus dz delta z. We have considered the two other things. Now last one is we need to take dz, dx, this is d delta y. So this is known as ds3. Okay. So how do we consider? We are not considering y direction. So we need to consider the area something like this, something like this. This is the surface we are looking at. What is the area we are, which is the direction now? This is delta y direction. Okay. So ultimately, the differential surface is nothing but ds1, ds2 plus ds3. So just add them. That is dx, dy, delta z plus dy, dz, delta x plus dz, dx, delta y. So this is our differential surface. Now, what is the differential volume? Differential volume is a scalar quantity. It is not, vector or something tensor. It is just a scalar quantity, capital V. This is capital V. So this is nothing but if you have any shape, length into breadth into height. So this is, so we can say, the differential length, that is dx delta x plus dy delta y plus uh, dz delta z, right? So dz, we have dz delta z direction. So in this, just multiply this, this, and this. So dx into dy into dz. This is total differential volume. Or why we are calling differential volume? Because we have taken a differential element. A differential element, we have taken a differential element of a small portion like this, which is having lengths as dx, dy, dz. So that is a calling, we are calling it as, so like this. Okay, we'll come back to the second one. That means we will take with the cylindrical coordinate system. Again, we'll try to obtain differential length, differential surface, differential volume.